Alright, calculus, welcome to introductory lessons here. We're going to be going through some background stuff that's going to help you think in the right perspective as you go into your calculus class. This first lesson one is just on the first page of the summer packet. Go ahead and open to it, pause the video if you need to, but we are going to get started. So I'm going to read it out loud as you guys read along here. It says, before we get into what calculus is, here are several examples of what you could do before calculus and then what you're going to be able to do at the end of calculus. So the first one here. On April 15th, many people mail their taxes to the Internal Revenue Service, also known as the IRS. The town of Newton, pun intended, monitors the number of tax forms that are mailed from their post office. The total number of tax forms that are mailed from the Newton post office on April 15th is modeled by this function. And it gives us time here along the bottom axis. If you look at this, it says from 12 midnight on the 14th to 12 midnight on the 15th. So that's 24 hours. So here's our 0 on this axis. It goes all the way up to 24. We got 18, 21, 24. So these are in intervals of 3. You can kind of see them there, but they're a little bit small. So that's the general idea of what's happening. As you see, like some people turn them in at first, and it gets really fast. And then as you get close to midnight here on the April 15th, it does slow down a little bit. People are probably going to sleep. So these are the things that you can look at. When you were in pre-calculus, you could find the number of tax forms mailed by 9 p.m. by just plugging it into the calculator. That's pretty much all you could do. If you were to look at the graph, it's about 2340. So at 9 p.m. right here, we could find about the number added together. It's kind of like adding these three numbers together. They would add up to about 2340. So and that's kind of like just plugging it in right into this equation here. So then the other thing that we're looking at is, or pardon me, not by 9 p.m. 9 p.m. Let's think about 9 p.m. on this graph. Where would 9 p.m. be? We know that it's not 9 hours because this is 12 midnight, so that'd be 9 a.m. So we got to add another 12 to that. So we'd get up to all the way here at 2100 hours if you were to think of it in military time. And that does equal about 2340. So that's where that number would come from. But when you're in calculus, once you've learned some calculus and you have some tools in your pocket that you can use, you can look at things like average rate, which you probably already know how to do, but you can get a more specific calculation for that. You can find the rate that tax forms are coming into the post office at 9. So how fast at 9 p.m.? You know, that's what we can look at, not just the actual value there, but how fast is that happening? Find the time of the day that when the letters are coming to the post office at the fastest rate. It's actually about 10:15 a.m. and if we take a look at the picture here, it's about here, about 10:15, right there in the middle. And you know that because we'll get more into that later, but the general idea is that the slope is greatest at that point. So if I were to draw like a line here that kind of looks like the slope, that's the most positive slope because we're still kind of positive everywhere else, but that's the most positive slope. So that's kind of what we're looking at right there. And then the last thing we can look at is what's the total number of hours that all the forms sit in the post office. Now that's kind of different because if you think about early forms, you know, ones that were turned in at 12 a.m., those are going to be sitting for approximately 24 hours. And then if you look at the late forms that are turned in just, you know, around midnight, those are at most maybe 1 hour, probably less. So some forms accumulate a lot of hours and some don't accumulate much, but you can actually calculate the total with both types of forms. These are things you can do with calculus. Let's look at how we might see this in another example here. A new car called the Sexus has its plant next to its only dealership. Cars are sold directly from the plant. So the plant makes cars and then it sells them. Suppose at the start of the month of May there are 100 cars on the lot waiting to be sold. Cars come off the assembly line at a rate of right here. And cars are sold at the same rate, 30 plus 15 cosine of 0.2t, where t represents the day of the month. From May 1st, t equals 0, 31st, t equals 30. So we got 0 right here. This is May 1st. And here, this is May 31st. What can you do with precalculus? Well, you can find the rate of cars produced on May 15th. And that's just by plugging it in. And the rate of cars produced is this blue line. I know you don't have colors on yours, but it's the non-wave type form. It does have a curve to it, but this would be the rate sold. Oh, pardon me. That's not the rate sold. That's the rate created. Here we go. Let's get these straight. This is the rate sold, which is, so this is the create or produce line. Okay, see, here we go. For the blue. And for the green line, that's when it's being sold. So we can only answer those kind of questions here on the left side, but once we get into calculus, we have so much more available to us. We could find the total number of cars available to be sold in the month of May. That's kind of like, how many did we have even that we could sell during that month? Find the total number of cars sold in May, the actual cars sold. That would be 879. Find the average number of cars produced per day. So it's kind of weird to think about, well, can't we just divide that, add them up and divide by the number they are? Well, you could kind of, but you're looking at a curve here where some days you can produce a lot, some days you can produce a little, other days you can produce less, and then it's varying, it's changing, and that's the key word. We are measuring things that change. No longer are we looking at constants. That was geometry, that was algebra, that was precalculus and below. Now we're looking at stuff that changes. On what day will there be a maximum number, or what day will there be a minimum number? Because you can imagine if we made a lot of cars, but not a lot we're selling, then that means that we'd have a maximum value. And if we're selling a lot of cars, but we don't really have a lot in the production house, then we're probably going to have a small amount out on the lot. Let's see how we can actually reflect on this. Now that you guys have listened to me talk plenty here, you want to think about some ways that you've heard this idea or concept of change described. So this is more of an English than a math type thing, but you can use your brain. You can use dictionaries right here. It says get your dictionaries out. You want to see how many different ways can you describe positive change, negative change, or no change. The most common ones that we see in a math class are the words increasing, decreasing, and constant. We'll talk about slopes, I guess you could say. I'm going to give you one set that kind of goes along with this. It has to do with money. You guys would probably understand that pretty well. Positive change, you could think of like the word deposit. Negative change, that would be a debit or a debt. And no change, well, there's no change in that. It's just the same balance. Same balance in the bank. Meaning that your money did not go up or down, it just stayed the same. So I want you guys to fill out the rest of these, think of what you can come up with. Feel free to post some comments in below in the video of what you did or what you think other people should put as well. Alright. And let's go on to this one. If you need to go back to the other one, go ahead and pause it while you do that. But I'm going to go ahead and keep moving on. So since calculus is the study of change, let's talk about change aroused. Give several things that are changing about you right now. Well, probably some of you have a clock. I have a clock around me, and that's changing. For sure, the temperature is changing. Hope your temperature is changing as well, keeping you cool or warm, depending on whatever you need at the moment. There's a lot of other things that are changing. I could say that my energy is changing. It goes down and up throughout the day. We want to keep it pretty high, but it does go up and down. And I'm going to say that my hunger changes. Because sometimes I'm hungry, and sometimes I'm not. Now these are kind of more abstract, but you can actually get very specific. You can talk about how your grade is changing. You can talk about how the accumulated debt in the country is changing. Now that's a big one. Okay, so actually I'm going to do that one real quick. The accumulated debt. And that's the one I'm going to talk about. Of the U.S. of A. We think we're all that, but man, we need some help with money. It says choose one. How do we know that change is occurring? Is change a constant? Is the change a constant change? I would say that we know because values are different over time. The change in this case is not constant. Hopefully it's actually getting better. Hopefully slowing down or decreasing, because our debt has been increasing quite a bit. Okay, in calculus we're going to study 4 main topics that have to do with this. They kind of support these ideas. So limits is the first one, and that sounds just like what it is. We're going to talk about the limit of something, and how to get closer to it, how to take it to the limit. And then derivatives is another one that's just a fancy way of saying slopes. Integrals, one kind, and integrals, another kind. Integrals have to do with an accumulation or an area kind of thing, but there's a lot of ways you can talk about them. And these are the big topics. And although we're not going to get into a lot of details right now, you're going to try and focus how can you key in on each of these topics and apply them to the questions that you're asked, especially for the AP test. So we're going to look at some introductory lessons that's going to focus on the derivative and the definite integral, two of the more simple concepts that can make sense to you now while not having had a ton of math background. Again, at the bottom you can see that these papers were found from mastermathmentor.com. This is the first page. Special thanks to Stu Schwartz. He is the guy that put this together. I'm just relaying it to you. So that's the end of lesson 1. I'm going to stop it here, and I hope that you guys have a great day. Go ahead and check out video 2 after you finish the work.